Okay, so here is the quick mini lesson for 9.8. So it's just solving logarithms. That's all it is. It's just solving logarithms. So we did a little bit of it last time, but this goes into it a little bit more. So the first one is solving by just taking the log of both sides. Because here it's hard to find what x is. X is going to be a decimal number, so it's not a nice exponent. So we're going to use logarithms to help us. So we're just going to take the log of both sides. Now, the only logs that are pretty easy for us to find and that we can put in our calculator are log base 10 or the natural log. So you need to make sure you do it using log base 10 when you're taking the logs, so you can actually use your calculator. So we're going to take the log of one side, so log of 3 raised to the x equals, and then what we do to one side, we have to do to the other. Okay, so we have the log of both sides. Now, last class, we learned a property with this exponent. What happens with this exponent? Well, remember, it can come out front. So we have x log of 3 equals log of 7. Okay, so remember, we're trying to solve for x to get x all by itself. So this is x times the log of 3. So to get x all by itself, we need to get rid of log of 3. So we need to divide. And again, what we do to one side, we do to the other. So we're left with x equals log of 7, log of 3. Now those are both log base 10, so can we stick those in our calculator? Yes. So when we stick it in our calculator, remember you type log 7, and then you can go divided by log 3, and that roughly equals 1.7712. We'll go to 4. So that's what we get. So that's one way we can solve an exponent that's going to be a decimal, is just by taking the log of both sides. So I want you to pause the video, and then I want you to try practice 1. And then when you're done, you can press play and I'll go over it. Okay, so we're going to take the log of both sides. Again, it needs to be log base 10 so we can actually use our calculator. And then, now that we've taken the log of both sides, the x can come in front, that exponent property. So we're just applying everything we've learned over the past couple days. Okay, now we want to get x by itself, so we're going to divide by log of 5 so they cancel out. Okay, and then that means we're going to have x equals log of 9 over log of 5. And again, we'll put that in our calculators, and we get 1.3652. Awesome. Okay, so now the next one, we're solving logarithmic equations that are actually in a log. So for this one, we need to recognize that the domain of a logarithm function is 0 to infinity, which means our answer must be positive. So if we get a negative answer, it's an extraneous solution. It cannot work. Okay, so just remember that we cannot have negative answers. So for this first one, we have a logarithm and we're trying to solve for x, and it's inside the logarithm. This is log base 4 of x minus 2. So it's not log times x, it's log of x. So we can't just divide by log, that doesn't work. So in order to get rid of a log, we need to use the opposite function. And the opposite function of a logarithm is an exponential function. So we need to convert this to an exponent. So what's the base of my exponent going to be? So remember, it's the base of my logarithm. So 4, so base 4. What's my exponent going to be? Well, it's what the logarithm equals. So 2. and that's going to equal x minus 2. Now we can easily solve for x. So first off, 4 squared is 16. And to get x by itself, we just add 2. So x equals 18. And then we just need to check 18 is positive, so we're good to go. Okay. So at any point you can pause this and try them on your own. This one's a little different in the sense that we have to use our log properties first to get one logarithm. Because remember, if they have the same base and we're adding them, we can condense that to one logarithm. We get log base 5 of x times x plus 4 equals 1. So let's just distribute that. So we have log base 5 of x squared plus 4x equals 1. So now we can do the same thing we did before. Write it as an exponential. So the base of the exponential is 5, the exponent's 1, and that equals x squared plus 4x. Okay, simplify that is just 5. Now I have an x squared. So that means it's quadratic. How do we solve quadratics? Well, we factor, and in order to factor, what has to happen on one side? It has to be 0. So we minus 5. So we have 0 equals x squared plus 4x minus 5. Now we have a quadratic. It's set up perfect to factor. And we can use our shortcut because there's no number in front of x squared. So just quickly, what adds to 4 and multiplies to negative 5? Well, that's going to be 5 and negative 1. So I get 0 equals x plus 5 and x minus 1. So what does x equal? X equals negative 5 and x equals 1. Although, can x equal a negative number? No, it can't. So it doesn't equal negative 5. It only equals 1. Okay, last one on this page, and then I think there's 2 word problems. Yeah. Okay, again, we can combine these using our log properties. So log base 10 of x plus 2 divided by x, and that equals 2. Okay, I'm sorry if you can hear my dishwasher. It's making some really weird noises. If you're hearing some high-pitched squealing. Okay, so again, let's make this an exponent. So, okay, so the base of our exponent is 10. Our exponent is 2. And that is x plus 2 over x. Okay, so 10 squared. Damn it, shut that off. Okay, 100 equals x plus 2 over x. Right, 10 squared is 100. So we need to get x all by itself. So first off, we don't want x on the bottom. So how do I get rid of x? Times both sides by x. So we have 100x equals x plus 2. Now to solve for x, we need all the x's on one side. So we're going to minus an x. So we have 99 x's, and that equals 2. Last thing, divide by 99. So x equals 2 over 99. And that's positive, so it's good to go. Okay, so that's solving. Okay, so when we have exponents that were hard to solve, we turn them into logarithms. When we had logarithms that were hard to solve, we turned them into exponents. Okay, now some word problems. And again, thankfully, these word problems give you the equations. We just need to know how to plug them in. So this first one is talking about population size. The population size y of a group of rabbits varies according to the relationship of this equation. In this formula, t is the time in years, and y naught is the initial population at time 0, so before it started. Estimate the population in 3 years if there was originally 60 rabbits. Okay, so originally 60 rabbits is our y naught, that y of 0. So we have y equals 60 times e, and our exponent of e is 0.916 times 3 years. Now, all we have to do is plug that into our calculator. And when we do that, we get 936.68, which this asks us to estimate the population of rabbits. So we need like an actual amount of rabbits, not point rabbits. So about 937 rabbits is what we get. Okay, awesome. Next one. How long does it take to take an investment of 2,000 to double if it is invested at 5% interest compounded quarterly round to the nearest year? So we're working in years. And it's asking how long does it take? So we're trying to find t. We don't know what the time is. That's what we're trying to find. So let's fill everything in that we know. We know that our investment that we start with is $2,000. We know that our rate is 5%. So remember, we got to put that as a decimal. So move the decimal place over 2. Can't put percents in here. And it says, so remember, we've done these a few times. So R is rate, and N is the amount of times it's compounded. Okay? So this says it's compounded quarterly. So we're thinking about years still, because that's what our times in is years. So quarterly, well, quarters are 4s. So that means it's compounded 4 times. That's what our N is. It's compounded 4 times. So in our exponent, we're going to have 4t. Now remember, t is what we're trying to find. So that means we actually do know what a is. So a, it's telling us how long does it take for our investment to double. So that means our 2,000 needs to double. So what's double of 2,000? Well, that's just 4,000. So awesome. We set up our equation, and now we can plug it into our calculator. So let's divide first by 2,000, because we're trying to find t, get t by itself. So we need to get rid of that 2,000 first. So that means 2,000 equals 1 plus 0.05 over 4 to the 4t. Now let's just simplify all this stuff in the parentheses. We can add all of that together. So 2,000 equals 1.0125 raised to the 4t. So now how do we solve that? Well, it was just like the first questions we did for this unit, or for this chapter. Okay, it is take the log of both sides. Okay, so again, what can I do with this exponent? Bring it out front. So I have log of 2,000 equals 4t times the log of 1.0125. Now divide both sides by log of 1.0125. Okay, and then we'll type this in our calculator. Let me type that in our calculator. Okay. 1 second to type that. Pull up my calculator. So log of 2,000 divided by log of 1.0125. Okay, then I get 611.8648, and that's what 4t equals. So again, we need to divide by 4. So we get t by itself. And so we get t equals 152.9662. The only thing is, if we look up here, it says round to the nearest year. So, let's see. Did I? Put the numbers in wrong? Oh, no wonder. I did something wrong. Sorry. I did some bad math here for a second. So if you go back up here, 4,000 divided by 2,000. We're dividing, not subtracting. So that does not equal 2,000. Sorry, you're probably wondering. It's 2. That's why the numbers are all big. Too big. Sometimes I just go on autopilot, and there we go. So now, if I put that in the calculator right, where it's 2 instead of 2,000, we get it equals 55.7976 divided by 4. And that gets us 13.9494. So then if we're rounding to the nearest year, it's going to be 14 years. Sorry about that. Did some simple math wrong, but it's always good to check to see if our answers don't make sense and see what we did wrong. So that's how we do that. So just to summarize, we're solving with logarithms and exponents. So to solve an exponent, we can change it to a logarithm, and to solve a logarithm, we can change it to an exponent. Okay.